Okay, so this is the third video in Math 83 for factoring. So we looked at greatest common factor. Please watch that video first. We looked at factoring by grouping. Please watch that video second. And now we'll look at factoring trinomials. So we know from our section on polynomials that a trinomial looks like this. Yeah, okay. I was just trying to figure out something I could factor. All right, so this is what a trinomial looks like. It's got three terms. So we're going to look at factoring things like this. So that was from our polynomial section. We also know from our multiplying polynomials section that we know how to, oh, I can't factor this. I'm going to have to figure out another one, huh? Let's do 8. Okay, so we also know from our multiplying polynomials section how to multiply two factors that look like this. So what we did to multiply those is we used the FOIL method. So we multiplied the first term by the first term. So that tells us that these two first terms have to make an x squared. So anytime we're factoring something like this, the two first terms have to multiply together to be the first term of our polynomial. After we did the first, then we did the outers plus the inners. So whenever we are factoring something like this, we know that the outers plus the inners have to come together to be that term. Okay, and then finally, we did the lasts. So when we're factoring something like this, we know that the last terms, these two numbers we're going to be multiplying together, have to have a product that is the same as the last number. And so that's going to be kind of our method of doing the factorization for a trinomial. Whenever we have a leading coefficient of 1, so whenever your first term in your polynomial that you're trying to factor is just an x squared without anything in front of it, here's going to be our method. We know that if our first terms have to be an x squared, the first terms in our factors each have to be an x. That's the only way we can get an x squared, by multiplying the first terms of our factors. Now, what we're looking for are these two numbers here. Now, we just saw that we got this middle term by doing outers plus inners. So what we know is that these two numbers, they're each going to get multiplied by x when we do outers plus inners. So we don't really have to worry about the x part there, but we have to worry about the coefficient. And the way we got the 8 here is that we did outers, 1x, plus inners, 7x. So the sum of these two numbers is what makes the 8. So the sum of these two numbers has to equal the middle coefficient. There we go. And the way we got the 7 up there is by doing the lasts, so multiplying the two numbers together. So these two numbers have to have a sum that's the same as the middle coefficient and a product, so when we multiply them together, we get the last number. We'll call it the constant. That's much more technical. Okay, so whenever we're factoring something like this where the leading coefficient's 1, so our first term is just x squared, what we have to think about is, first of all, the format of our factors. So if we just have an x squared, our factors are going to look like x and a number and x and a number. So we know the format right away. It's these two numbers we have to figure out. So these two numbers, we need to think of two numbers that have a product that's the same as the constant term, so this term over here without a variable, and the sum is the same as the middle coefficient. We don't really have to consider the x because that doesn't really make a difference what the numbers are. It's always going to have an x on it. So we need to look at that middle coefficient. So this is really kind of a process of elimination. You want to think about two numbers that have a sum that is the same as the middle term and a product, or the middle coefficient, and a product that is the same as the constant term. Okay, so let's do some examples. And I kind of looked at our first example in our notes to be able to show that process. So A is going to be different. I'll make up a new one for A. So let's try to factor x squared plus 5x plus 6. Yeah, that's not one we planned, so that'll be a good one. Okay, now what we just talked about, we're trying to reverse the FOIL method here. So we know our leading coefficient here is 1 because our first term is just x squared. So we know our factors are going to look like x and a number and x and a number. All right, now we just talked about these two numbers that appear in the factors that will be added to the x's or subtracted if they're negative, have to have a product that is the same as the constant and a sum that is the same as the middle coefficient, the linear coefficient we call it. Okay, so now what we start doing is figuring out some factors of 6 that add to 5. Now this one is pretty easy, it's pretty quick, but normally what you would do if you have more factors than 6 does, and you don't think of the one right away that adds to 5, what you would normally do is try to bring your work down a little bit. Try to lessen the number of factors you have to consider. What we see here is that the product is 6. Well, if the product is 6, that's positive, which means the factors we're looking at have to have the same sign, right? They either both have to be positive or they both have to be negative. But since our sum is positive, we know we're looking for two positive factors of 6. So we're not even going to consider that both the factors are negative. They'd never have a positive sum. So let's start looking at factors of 6. Okay, so we'll start with the easy one, 6 and 1. These have a product of 6. Do they have a sum of 5? No. Okay, so we can't use those. Now let's look at the next ones, 2 and 3. They definitely have a product of 6. Do they have a sum of 5? Yes. So these are our two numbers that complete our factors. And if you want, you can always check by foiling or doing the distributive property. So first times first is x squared. That's good. Outers, 3x. Inners, 2x. Add together a 3x and a 2x, and we get a 5x. And finally, the last 2 times 3 make 6. So we factored correctly. And this would be our answer. Okay, so that's how we factor things that have a leading coefficient of 1. Let's do some more just so we get comfortable with it. Okay, so let's look at this next one. X squared minus 3x plus 2. Okay, so once again, we have a leading coefficient that is 1. So we know our factors are going to look like that. Okay, so now we also know that these two factors have to have a product that is the same as the constant term, so positive 2, and a sum that is the same as the middle coefficient, so negative 3. So now again, let's use a little bit of logic to kind of take our number of factors we have to consider down. Again, 2 doesn't have very many factors, but what we know is that since the product is positive, the two factors we're considering have the same sign. They're either both positive or both negative. That's the only way we can get a positive product. But since the sum is negative, we know they both have to be negative. So we're only going to consider negative factors of 2. Well, that's not very hard because 2 is a prime number. So the negative factors of 2 are negative 1 and negative 2. They certainly have a product of 2. When we add them, do we get negative 3? Yes. So there we go. Negative 1, negative 2. So our factors are x minus 1 and x minus 2. You can always check your factors by distributing back out or foiling back out. And what do we get? X squared. Yep. Minus 2x minus 1x minus 3x. And finally, negative 1 times negative 2 plus 2. So we factored it. Okay, let's do 2 more of these, and then we'll look at a situation in the next video where the leading coefficient is not 1. Okay, so this is C. Let's look at x squared minus 3x minus 10. Okay, so again, and I moved my phone. Okay, so once again, we have a leading coefficient of 1, so we know what our factors are going to look like right away, x and x. Okay, now to figure out these other numbers in our factor. Well, our factors. So we know they have to have a product of -10. We know that they have to have a sum of -3. Okay, so we need to start thinking of factors of -10 that add to -3. What we know, since the product is negative, is that these have to have opposite signs. One has to be positive, one has to be negative. So we know we're not looking at, for instance, 1 and 10. There's no way that gives us a -10 when we multiply them together. But the sum has to be negative. So not only do these have to have different signs, but the bigger number has to be negative, because when we add them together, we need something negative. So whenever we start thinking of our factors of -10, we don't want to think of -1 and +10. That will never give us a negative sum. We want to think of -10 and +1, because that kind of sum is negative. Now you can try out every single factor of -10 that you want. That's fine. Just thinking about it that way kind of cut your work down a little bit. So -10 and 1, those definitely make a -10 whenever we multiply them together. Do they make a -3 when we add? No. Now we could try -2 and -2 and 5 if we want, but we know that it's never going to be a negative sum. So let's go straight to -5 and 2. They definitely have a product of -10, and when we add them together, they have a sum of -3. Those are our numbers, -5, -2. You can hear a cat outside the door. All right, so these are our factors, and if you want to check, you can. Firsts, x squared, plus 2. Okay, x squared. Outers, 2x minus 5x minus 3x. Good job. -5 plus 2, or sorry, -5 times 2 is -10. So these are our factors. Okay, one more. Okay, I need wireless earbuds. That's what I need. Okay, one more. So x squared minus 4x plus 12. All right, so we know if this thing factors, each one of our factors has to have just an x. Okay, because we have to have an x squared. Now these two numbers here have to have a product of 12 and a sum of -4. So because the product is positive, it means that both of these numbers either have to both be positive or both be negative. And since the sum is negative, they'd have to both be negative. That's what it would seem like. All right, so let's start looking at factors. Let's look at -12 and -1. They definitely have a product of 12, but they do not have a sum of -4, so those are not going to work. All right, how about -6 and -2? Definitely have a product of positive 12, but when we add them together, that's not -4, that's -8. So no. Okay, let's try -4 and -3. Definitely have a product of positive 12, but when we add them, we don't have a sum of -4, so those don't work either. I don't think this thing factors, because if it did, we'd be able to find some factors of positive 12 that add to -4. I mean, we could start trying positive factors, but there's no way they're going to have a sum of -4. So if you ever run into this, that you have tried everything and nothing is working out, it is possible that what you're trying to factor doesn't factor. So what I usually say is, if you've tried it, I'd say twice, maybe 3 times, and you still cannot get it to factor, the answer might be does not factor. And that's okay. That is sometimes the answer. We call this a prime polynomial, it doesn't have any factors other than 1 and itself. Okay, so that's factoring things that have or polynomials that have a leading coefficient of 1. In the next video, we'll talk about what to do if your leading coefficient is something other than 1.